The Government Communications Headquarters Puzzle Book. I had it for quite a while now, and players, I'll be honest with you, I think I'm too stupid to solve most of these puzzles. But we live in the 21st century. We have AI to do all our work for us and think for us. Also, ignore the Kaipamas on the desk, not important. My name is Janek, and today I'm going to ask 10 different language models to solve a few puzzles from this book. I picked 15 questions from the starter puzzle section of this book. I explicitly avoided any puzzles that might involve mathematics or numbers in it. As general, the LLMs are really bad at math. I put the questions and accompanying answers in a JSON file and wrote a script that will loop over them and ask them to 10 different models based on Llama and Llama 2. For comparison, I asked the same questions to the bigger models, ChatGPT and BART. Finally, I asked ChatGPT for a bit of help to create a stylized HTML with some JavaScript to help us display it in a more visually pleasing way. Let's have a closer look at how it's done. As per usual, we'll start in the terminal. We'll first look at the questions. I created a list of objects, each containing 3 fields. The number is referencing question number in the book. The question value contains the header title of the question, as in some cases it contains a clue about the puzzle. Then on a new line, it contains the puzzle question itself. And finally, the answer contains the solution as provided in the book. The number field is not going to be used anywhere in the code, it's purely for my reference. Next, let's have a look at the models JSON. This is where I specify which models will be loaded for this evaluation. Main key is the short name of the model, including the quantization. I ran only the 13 billion 8-bit and 33 billion 4-bit models. I only have 24 gigs of VRAM available and I wasn't able to load any bigger models. The path is the location on the disk where the model will be loaded, and prompt template specifies which type of prompt will be used for this model. The templates are defined directly in the code. Let's check it out. First, we are importing some standard libraries, and then we are importing llama from the llama-cpp. These are our prompt templates. So we are using 3 templates today: llama 2 chat, vicuña, and vicuña with no hashes. Different models will use different templates as specified in the models templates file. We will be running 3 different temperature settings against each model to have a variety of responses from the same model. We are loading the models from the models JSON file, and then we are loading the questions from the questions JSON file. Verify models is used as a first thing. Have a look here. We are using it to check if any of the models listed in the models JSON file actually exist. So we don't want a situation where we are running like a 5th loop and then one of the models had a typo and it didn't load. Save results function will be saving the results of our questions in a file. Construct question prepares the question for each of the iterations. Preface is where we specify to the model what we actually wanted to do with the puzzle. So in this specific example, I wrote, here's a puzzle from a book. It can be a play of words, logic puzzle, cryptic, or any other type of language puzzle. Solve it and provide a direct answer. I tried some other prompts in the past and they had somewhat worse responses, not very direct, so I'm guessing this can make a big difference in any future evaluation. Over here we do some basic string manipulation, loading the values from the JSON files, and then in the end constructing the whole prompt. And our main function is where we loop over the models. So first we loop over models. For each of them we create the LLM object, which is the llama interface. We load specific model, offload it to GPU. The good thing about llama-cpp is that it doesn't require a specific number. Like if the number is bigger than the amount of layers, it will still load all of the layers. We are creating empty list for our model results. This is what we will eventually save into a file. And then we start looping over each question. We are getting the prompt and stop sign from the construct question function. We're preparing the basic layout for our output. This is where we'll save the question, the list of answers, and the correct answer. Finally, we are looping for each temperature. This is to have the 3 different answers. We're creating the output from our LLM, providing the prompt, max tokens. We don't want to echo the question itself back to us. And we're serving the stop sign, which can vary based on the prompt template. We are extracting our answer, resetting the state of the model. This makes sure that the model doesn't store any context and each question that we ask is fresh. We are appending the list of our answers with the answer for each temperature, and then finally appending each question to the model results. We are saving the model results into the file, and then deleting the LLM object. This will help to free up the memory next time it's initialized. Without that, I ran into problems where the script was going out of memory. I ran that on an NVIDIA P40. It took just under 2 hours. While running this, I was also collecting some basic metrics about the card utilization in a CSV file so that I can graph them later in a spreadsheet. As you can see, it was probably throttling on the GPU temperature. These cards are pain to cool at home. You can also see that the bigger models, the 33B models, were using more VRAM, almost all of the available VRAM. So what about the results? We have 10 output files, each containing the structured JSON that we can then render or we can view. I spent some time with ChatGPT to create a JavaScript that loads and renders the JSON files. We have some 3 basic functions. One is to fetch the JSON file from the file name, process the JSON file. This is what creates a nicely visible table for us. And this is where we invoke it. One caveat here is that I didn't want to run JS Node or anything else locally to access the files. Hence it's loading the file list from another JSON file. The file will be generated by the display.py script. This will be our basic HTTP server that will display the index file for us. We're specifying host on which we listen and the port. By specifying the 0000, that means that it will be accessible from outside. We are specifying where our answers files are. So this is what we will be listing, and we basically create the file list with the glob. We write that file list to our available files JSON. This is what the JS script will load. And then we start the HTTP server to serve the index file. We can run it and look at our answers. So over here I'm connecting to my local network, but if you ever run it by yourself and you're running it on your local host, then you need to obviously type in localhost. So let's have a look at some of the answers. We can select our answer file from the drop down here. By default, the first one will be loaded. Let's have a look at some of the questions. Title, the early bird question. What can be African, emperor, little, and macaroni? This is the only question that I actually expected any of the language models to answer. So this can be solved relatively easily. Like if you know African and emperor penguins, like yeah, the answer is these are all species of penguins. And as you can see, we're not to a great start. So the answer to the puzzle is Napoleon. And I tell you, like some of the explanations that the language models try to give are hilarious. Yeah, Raven. With most of those puzzles, they found that they are heavily based on wordplay, and they also have some pre-requirements on very British or English specific knowledge. So let's have a look at some other examples from Vicuña. Title, concealed animal. Question, here's a list of animals, but which other animal is hiding? We have raccoon, parrot, lemming, kookaburra, aardvark, linnet, and otter. Correct answer would be cormorant, and this is because of the double letters. So like every double letter in the word creates another word. As you can see, none of the temperatures got it right. So my temperature selection here is 07 for like very strict, and 08, which is the default setting for llama-cpp, and then 1, which should be a bit more creative. Let's have a look if we can find any correct answers in the list. So a round of drinks, correct should be tea. We don't have it. Terry, we don't have it. This specific question requires like pre-existing knowledge of Monty Python. Friends in other countries, this is a wordplay, and Hungary is the answer, which is not there. Question to put you to sleep. 40. These are completely wrong. Hoop, which is backwards of poo. Again, nothing here. Odd one out, firm. So we have a correct answer here, but the explanation for it is not correct. So each word contains a tree and an extra letter, and firm is the only one that contains extra letter at the end. And the model said the odd one out is firm. The other 3 words are verbs related to water or cleaning. Nah, that's not right. So that's a lucky guess. The magic word, so this requires pre-existing knowledge of Harry Potter. The solution should be Harry Potter and the. None of them are correct. Apart from being names, what do the following have in common? And what they have in common, they can be another name. Male, female, no. Nothing right here. Missing country question. So it should be Madagascar, also based on the repeating letters in the word. which is not correct here. This puzzle is really hard to solve for humans as well. I tried it with my friends and with my wife. They didn't get it. It's rather obscure. Like, the deduction you do over there doesn't make sense for humans, so I would be surprised if it made sense for people. But there we go, Liverpool. This can be succeeded by a letter in the NATO phonetic alphabet. The other can be preceded by one. The sequence involves 5 letters. Alfa Romeo, Bravo 20, Charlie Brown, Delta Force, and Liverpool Echo. So you have to have a lot of cross references to brands, popular culture, media. Yeah, makes no sense. And the odd one out is Liverpool. The model guessed it twice, but in both of the answers, they are not correct. Also, lucky guess, we can say. Right, another question. What links the following? This is another wordplay question, which is close to impossible for any normal human being to solve. So yeah, if any of the questions would say anything about orchestra, I would be surprised. But yeah, no, they are all wrong. And the final question which we have, spot the link. What links? A golf course website, navigation, deodorant, Nintendo characters, and a cat. And this requires a lot of references to be known in advance. However, at the default temperature, the answer is correct. All of these questions have, all of these items have some connection to a word link. A golf course is a place where people play golf, which often involves hitting a ball from one link or hole to another link on the course. Website navigation refers to users. Basically, this is a good answer that accounts for the wordplay. So out of Vicuña 13b, we got 2 out of 15 correct, and then 1 lucky guess. Well, now that I think of it, it's not actually 2 out of 15, it's more like 2 out of 45 because we have like 3 different temperature settings. So we have 45 different answers. Let's look at another model. We have a bigger model, maybe Upstage Llama 30b. I'm not going to go through all of those models, by the way. I'm going to link everything in a GitHub, so the answers will be available over there. You can look through them at your own. This model did not answer the first question either, so the penguin is not correct. Second one, wrong. Next one, wrong, 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 and wrong. So for this specific model, Upstage Llama 30b, it got 0 out of 45. Not great. I'm gonna show you a couple more. Not gonna look at all the questions, but there are some interesting things that happened. Godzilla. This model really likes to write a lot. So if you just look at all the answers, they are very, very fleshed out. However, when I looked at all the answers, also none of them are correct. So it writes a lot, but there is no correct answers here. Actually, no, sorry, there is one correct answer. It's for this question. So find the whole number that can be spelled out and has a letter in alphabet order. At the temperature 1, which is the bit more creative temperature, it gave the answer 40. Let's look at another model, Llama 2 Chat. This is an interesting thing because I ran the evaluation a few times, and one of the times I did get the correct answer here. But I see that this time it did not give the correct answer. For this question, Llama 2 Chat gave a correct answer, however, it's just a guess. It does state Terry, but the explanation is not correct. It's the same story over here. It does give the correct answer, but the explanation is not correct. So it's not the same logic as in the original answer. Llama 2 Chat also is a bit more aware of the Harry Potter reference, but it doesn't get the answer correctly. So it does know that they refer to the Harry Potter books or the Harry Potter itself, but the answer to the puzzle is not correct. And it's another lucky guess over here that the odd word is described as Liverpool, in this case in every single temperature setting. But again, the explanation is never the same as the correct answer to this puzzle. And apparently the link between golf course website navigation, deodorant, and Nintendo characters in a cat is the smell. So Llama 2 Chat, some lucky guesses but no correct answers. And the last thing that I want to show in this video is the answers for the Guanaco model. This is the Guanaco 33B Super Hot 8K, and I think it's broken. It's cursed. None of the questions were answered in a legible way. I'm not sure if this is something specific to that model file or the settings that I used to load it. I mean, it loaded the same way, it was loaded the same way as all the other models, but this one did not produce any reasonable output. I asked the same questions to the big boys, ChatGPT and Bard. Most of the answers weren't any better, so I asked them in the exact same format, I used the exact same prompt, and I created new session for every single question just to make sure that the model doesn't follow the context. So the answers weren't any better. Like it was marginally better, but comparable to Vicuña. So ChatGPT managed to get 3 out of 15 correct, which was the same case for Vicuña. And as for Bard, this actually surprised me because it got quite a lot of them correct. I think total of 6 questions were answered correctly, one of which was a lucky guess. So we have 5 correct answers with explanations. And also something I noticed with Bard is for a lot of those questions, it tried to give me code to solve it for no really good reason. I suppose that's how Google tries to train their model to help with a lot of coding solutions. Yeah, as you can see it over here. And usually wherever it gave a code, it was also wrong. This question specifically is the one where it got the lucky guess, but not the correct answer. But yeah, overall, I'm quite impressed with Bard. Some of the most obscure references were done correctly. So like it got the reference for the Harry Potter, but that the answer is not correct. And this also cracked me up because the link between golf course website navigation deodorant and Nintendo characters and a cat is meow. Some of the explanations that the model gives for the reasoning behind the answer is amazing. So what is the conclusion then? Well, there are 3 main takeaways. First is that it's quite easy to run multiple evaluations for multiple questions across language models. Second is that the language models as of today aren't great at solving abstract puzzles. And finally, the third one is that maybe I'm not that stupid, but rather some of the puzzles in this book are rubbish. I hope you learned something. Have a nice day. Bye.